Good afternoon. The next hearing today is on the application by Best Theratronics Limited to obtain a Class 1B license for its facility located in Ottawa, Ontario. Mark?
So this is a one-day public hearing. The notice of hearing 2014 H2 was published on February 10th, and a revised notice was published on March 7th to extend the deadlines for filing of documents from CNSC staff and interveners. The submission from BEST was filed on March 7th, and the submission filed by CNSC staff was filed on March 14th. The public was invited to participate by written submission and oral presentation. April 14th was a deadline set for filing by interveners, and the Commission received one request for intervention. April 30th was the deadline for filing of supplementary information, and presentations have been filed by CNSC staff and Best Theratronics. Mr. President.
Thank you. So I'd like to start the hearing by calling on the presentation from Best Theratronics Limited as outlined in Commission Member Document 14H 3.1 and H 3.1A. And I understand that Mr. Wassenaar will make the presentation. Please proceed.
Richard Wassenaar for the record. Thank you very much for this opportunity. I would first like to send regrets on behalf of our president, who was initially scheduled to be here. He had rearranged his schedule to make sure he had the time. Unfortunately, for medical reasons, he was unable to travel to Ottawa, and so he's unable to be with us today. Instead, I have Jeff Biggs, our Director of Manufacturing and Facilities Operation, as well as Moshkin and Sam, two of our key radiation safety personnel. So with that, I'd like to start our presentation. My presentation is essentially broken up into two parts, sort of because this is our first application rather than a renewal. I wanted to spend about half the time, not quite, sort of going over who we are and what we do. I think that would give you guys a good understanding of what we're looking for. And then in the second half, why we're here asking for a Class 1B license, and well, why you should give us one. We are a privately owned company called Best Theratronics, located here in Ottawa, out in Canada, actually right beside Nordion. And I'll go through our history. We have a history that has at times been part of Nordion and part of ACL. But currently we are privately owned. Our owner, Krishnan Suthatharan, owns a number of various healthcare companies scattered around both North America and internationally. I want to stress that each company is a private entity out of itself, so we are not a subsidiary of another company of Best Medical International or anything like that. We are a standalone entity. So we are part of the Best Medical Team, or Best Team of Companies, as Chris refers to us. The values and missions for ourselves and this group of companies is for the development of products to help in prevention, detection, and treatment of cancer. And so our product line, as you'll see, fit very well into that structure. And our aim is to be the one partner that clinicians will turn to. Our key themes are things like healthcare for all, cost-effective solutions, and quality service and care. Our history. As Best Theratronics, we've been around since about 2008, but as a company doing this type of work, we've been around for a very long time. We were once part of Atomic Energy of Canada Limited back in '46. Well, that's when ACL started. One of the key points in our history was in 1951, I believe in October, was the first treatment in the world, which happened in London, Ontario, of a patient using cobalt-60. That was our initial product line, and that's one we still continue today, as you'll see. In the mid-'60s, we moved out to March Road. We were still part of AACL. Later on, ACL formed two divisions, the medical division and the industrial division. The industrial division became Nordion at a later point. The medical division was a crown corporation that became Theratronics. A number of years later, in the late 90s, Theratronics was bought out by Nordion, so we became one family again under the Nordion name. And then in 2008, Nordion divested this part of the business, the Theratronics aspect of the business, which was purchased by Krishnan Suthatharan And now we are privately held, and we are now named Best Theratronics, the company that has the license application before you today. This is our facility. We're located on March Road, right on the corner of March and Carling. Like I said, this facility has been there since about '65 with a few minor additions in the early '70s. And since then, it has remained relatively unchanged on the outside. What we do, we are a manufacturing facility primarily. So we're about 100,000 square foot shop. We bring in raw materials, raw steel, copper, lead, et cetera. We machine it, we mill it, we assemble it, and we ship out products. And those products are blood irradiators, teletherapy units, and now cyclotrons, which is one of the triggers for this particular application. We're a highly skilled workforce, somewhere on the order of about 160 people located in our manufacturing facilities. This includes engineers, physicists, and tradespeople. And we have a worldwide installation base. So our products are sold across the world, almost in every country. About 1,000 teletherapy units, close to 2,000 gamma cell units, which is the blood irradiator, and somewhere on the order of about 200 ray cells, which is an X-ray based blood irradiator, and I will get into that a bit more. What we did first and what we continue to do is cobalt-60 teletherapy. This was, of course, the Canadian invention that started a new paradigm of radiation therapy. Canada Post, actually a little while back, commemorated it in a stamp. That head you see, the therapy head and treating the radiation, basically you have a cobalt-60 source on a drawer that slides back and forth from a shielded to an unshielded position for treatment. Very simple, very robust, very cost-effective solution for many countries in the world still today. That head you see on the stamp was the original head, more or less, and it really hasn't changed in the 50 years we've been making teletherapy units. That being said, we have changed the units quite a bit. So recently, in the past 8 years since we've been Best Theratronics, we've actually put a lot of R&D in. So the device that was sold in the 50s, even though the guts remains the same, there have been a lot of advancements to things like the electronics, so that we now have a very advanced therapy system. Again, this is sold worldwide, and we have several models. We have the model you see in the picture, which is our advanced system. We also have a scaled-down version, which would be more appropriate for countries where power supplies may be limiting. We've also done a lot of R&D. So we're implementing options such as a multi-leaf collimator. So Linux today, linear accelerators used for treatment. You can do things like conformal therapy, IMRT. That hadn't been previously done on cobalt-60, and we have an active research program to do that. And in the corner, you actually see one of our physicists. We have an on-site, fully operational cobalt-60 unit, which is part of the license activities we're looking for that we use for this type of development. And you see one of our physicists working on it. We also make, again, same head, different body, what we call the gamma beam. This is used for research purposes. In particular, a lot of standards labs for dosimetry will use this as a reference measurement. Cobalt-60 is a very good reference measurement because of the high penetration of the energy and the well-known decay and energy of the cobalt. The other product line we've been building for many decades is the blood irradiators. Here you see on the top row what we call the gamma cells, which is a cesium-137 based unit. In the schematics on the right, the blue there would be a cesium 1 or 2 or 3 sources. Basically, you put your blood bags into that canister. The machine rotates into the radiation field, irradiates the sample, kills off the T lymphocytes, so that you can inject the blood into a donor host without having to worry about into the patient without having to worry about the donor blood attacking the patient, essentially. We also make an X-ray based version as well, which is what you see on the bottom. The license we're asking for would include activities related to manufacturing and testing of the the gamma cells, the cesium based activity. The X-ray, of course, falls outside the jurisdiction for CNSC. Our newest product and one of the triggers for this license application is cyclotrons. So when Krish bought us in 2008, he had a vision to also look at cyclotron production, primarily, again, for getting that one-stop shop of producing isotopes for diagnostics and then having the endpoint of treatment of cancer as well. So the whole line. And I want to be clear, what we're doing and what we're applying for is for manufacturing of cyclotrons. It's not to set up a cyclotron facility that will produce isotopes or a test facility. It's design of cyclotrons, it's supply of cyclotrons to those who want to buy them. So it would be design cyclotrons, manufacture cyclotrons, test, and ship. And we're also looking at things like supplying the targets. So we would have a program for designing targets as well as designing bunkers for the cyclotrons. We have approximately 3 products of cyclotrons that we're looking at. We have what we call the 14P, which is 15P, which is a 15 mega electron volt cyclotron, the kind you would typically find in a hospital for PET tracer production. We are also making a 70P cyclotron, which can be used for isotope production as well, but also for research. And we have one under production in our facility that is purchased by the Italian National Lab and set to ship later this year. And there you see a picture of it in our facility. Part of the license we'll be asking for is for testing of this cyclotron up to 70 MeV. So again, we're manufacturing, we want to test, and then we would dismantle and ship. And there are just some images of how large that 70 MeV really is. There you see in one corner the magnets, the steel used for one of the magnets, top or bottom half, and then the picture on the right, you see them putting the copper coils on the magnet to produce the electromagnetic field. That is who we are and what we're doing. The reason we want a Class 1B license is as follows. We currently hold 5 licenses. We're in the process of getting a 5th license related to service, and we can discuss that's further on with the CNSC. These licenses are with the Nuclear Substance Directorate or the Class 2 Facilities Directorate. What we're looking is for more flexibility to be able to respond to market changes, as well as flexibility in our products and what we can offer, such as cyclotrons, and we have a few other products that we're looking at down the road. So we've had a number of discussions with the CNSC over the past few years, and it was determined that a Class 1B license would provide the structure and framework we needed to undertake our current activities and any future proposed activities. Our Class 1B activities would include essentially everything currently on our licenses, which means import, export, possession, usage, storage of cesium-137 and cobalt-60 CO2 sources. These are Category 1 CO2 sources primarily, and sometimes they have decayed to Category 2. It would include possession and storage of depleted uranium, which was previously used in older model teletherapy units, and so is a legacy product we sometimes still deal with. It would include device manufacturing, and it would include operation of an R&D cobalt-60 unit. These first 4 points are currently covered under our licenses and would be rolled into a new Class 1B license. The significant change in the Class 1B license, what we're asking for that is new and not on a current license, is testing of cyclotrons to energies greater than 1 MeV but less than 70. So of course, testing to higher than 50 moves us into a Class 1B regime. Class 1B would consolidate 3 of our existing licenses, which I've listed there. We would still have to maintain 2 licenses outside of our Class 1B for service work within Canada. And talking with the CNSC, we had a number of discussions about whether they could be rolled into a Class 1B or not, and it was decided that because of the type of license a Class 1B is, facility-based, service would not be included or could not be included. And we would need 2 licenses for service, one for the gamma cells and one for the Class 2 equipment. We have submitted our documentation to the CNSC staff to address the various safety and control areas, and I believe, and I think the CNSC staff document as well shows that we are qualified to undertake the proposed activities, and that we have indeed made adequate provisions for protection of both the environment, our employees, and the public. We are an ISO 9001 company, and that has stemmed from the fact that we are a manufacturer of medical equipment. So we have always been ISO certified, or for a significant amount of time. We are privately owned. Oversight of day-to-day activities is provided by the senior management team, which includes myself and Mr. Biggs beside me. As well, we've developed a very extensive procedural framework that defines roles and responsibilities for personnel. Our Class 1B license triggered an environmental assessment in which we hired a third-party consultant to undertake on our behalf. That was prepared in late 2012, early 2013. We submitted it, CNSC reviewed it, performed an environmental assessment, and that was sent out for public review a while back. The conclusion of the environmental impact statement that we submitted was that our activities and the proposed activities of the Class 1B license would not result in any significant environmental effects. We've been working with radiation for a very long time, since our beginning. So we have a very extensive radiation protection program and a very robust ALARA program. Here is an overview of the doses we've had since we've been Best Theratronics. So this includes service personnel as well who work on the devices, manufacturing personnel working on the devices, and anybody considered nuclear energy worker. As you can see, we have a number who are considered nuclear energy workers and are badged, and the vast majority fall below 0.5 millisievert. Typically, every year we have maybe one that is above 1 millisievert, but is below 5. So we have a very robust program. We also have a very robust health and safety program. We believe we have a very strong record. You'll notice that the number of injuries seem to be increasing, and that was because 2 or 3 years ago we became more restrictive in reporting these. So basically we began reporting more of the smaller health and safety injuries. So anything that required a Band-Aid essentially had to be reported. So that's why you see a jump in that. But again, this is monitored monthly by our Health and Safety Committee, which is made up of both management and union staff. So it's half and half representation. And they meet monthly to go over the statistics and any areas of concern. Now, in the last few slides, I'd like to concentrate on the newest activity, and that is cyclotrons. What we're asking for is to be able to test cyclotrons for the purposes of factory acceptance testing to greater than 1 MeV. We have developed a cyclotron operating room instructions, which does define how operators are to work to minimize their dose and the dose to those around them. We will be developing a cyclotron dismantling procedure as well, which will define how we dismantle and measure the cyclotron components to make sure that they are not activated and are okay for transport. For testing, we've had to design a bunker. Now, this bunker fits within the current facility, so we have not had to increase the footprint of our facility. We've managed to do this internally. As well, because we're a manufacturer, we're not building one cyclotron for testing or use. We want the ability to test multiple cyclotrons as the need may occur. We've designed a modular bunker, which you see here, the circle in the center. The modular bunker is made up of a number of concrete panels, which will be for easy removal. So this bunker can be removed or erected as needed. And the main target is within a more solid concrete cave up in the left-hand corner. Our initial estimates had the dose to operators at about 2.5 millisieverts per year, which is well within our administrative limits. As well, we've also, based off of that, and based off of some engineering requirements, made the walls thicker than they needed to be. So we expect that dose to be reduced. In conclusion, I'd like to reiterate that we're here for the Class 1B license because in consultation with the CNSC, we believe this will provide the framework we need for growing our business in the future. We have a number of new products as well that we foresee maybe coming down the road, and we want to make sure that whatever framework we have, we'll be able to meet that. As well, we are qualified to undertake the proposed activities. So in ending, I'd like to say again that we are committed to ensuring the safety of the environment, of our employees, and of the public. And I'd like to thank you for your attention, and if there are any questions, I would be happy to take them.